and I'd like to welcome all of you who could join. Let's begin today with a few words about this Earth Engine India Community on Air event. This is a webinar series planned and organized by the recently launched Earth Engine India Users Community, which is an online community of Earth Engine users and enthusiasts based in or working on India-specific themes involving geospatial and remote sense data. Each webinar will be structured to combine showcasing of projects by members of the community for inspiration, sharing of skills for learning, and live questions and answers at the end to foster collaboration and interactions. Today is the first webinar in the series, and we plan to have recurring such events once a month going forward. My name is Pradeep, and I'd like to welcome you all. So, just a sec. Along with me today is Dsouza, a fellow member of our community, MD Madhusudan, who's also a fellow member of our community, and two guest speakers and members of the community from Google Earth Engine and Earth Outreach teams at Google India. We'll quickly introduce ourselves before getting started with the main parts of the webinar. I'll start first. I'm Pradeep Koulgi, and I'm an ecologist based in Bangalore. I work as an independent researcher on projects related to ecology and conservation science. I've been working with Earth Engine for almost 2 years now. Over to you, Craig.
Hi, everyone. My name is Craig. I'm based in Pune. I'm also an independent researcher like Pradeep, and my domain is water resources management, hydrology, things like that. And I'm also part of a network, an open data network called Data Meet, which is basically open data enthusiasts in different parts of India sharing advice, tips on how to work with public domain data.
Hi, I'm Madhu. I'm Madhusudan. I'm an ecologist again by training. I work with the Nature Conservation Foundation in Mysore. I have mostly been using Earth Engine for ecology and conservation related projects on which I have worked for the last 4 years. So I look forward to being part of this community and the community on air and sharing what I know and learning what all of you have to share.
Hi, everyone. My name is Ujaval Gandhi. I work at Google Bangalore, and I'm part of the Earth Engine team here. As part of my job, I do engage with the community and also do a bunch of trainings. Some of you may have attended the Intro to Earth Engine training that we have done over the last year in India. And I really want to thank Craig, Pradeep, and Madhu for creating this unique space for Indian users and also inviting us here today. Very excited and looking forward to the discussion.
Hi. Sorry about that. Hi, I'm Devja, and I've probably met some of you at some point of time or the other at one of our workshops. And I work as a project coordinator on the Geo for Good India team. And I help put together community initiatives like workshops, trainings, and a lot of other things. So we're excited to be here, and we have a lot planned for next year as well. So hope you enjoy this session today.
Thanks, everyone. Thanks for the introductions. So we'll get down to it. To start off for today, we'll have a showcase of a project that Craig has been working on for some time now. We'd like to have him say a few words about his project. Craig?
Yeah, thanks, Pradeep. I guess you guys can see my screen already. I've begun sharing screen. So I'll just switch over to one of the earliest scripts that I came across in Earth Engine. So just a little bit about finding data and specific to water resources in India is extremely difficult. I guess many of you in the audience may already know about that if it is your domain, if you've worked in this area from time to time. So one of the things that I found most exciting about using Earth Engine was just the fact that so much data was there. It was readily accessible. In you barely had to do anything, and within a minute or so, you had a script, you had a whole data set which you could just run and view analysis for your area of interest. So I'm going to talk a little bit about the CHIRPS dataset. So CHIRPS is basically a precipitation dataset that is based on the precipitation dataset. It's an algorithm actually based on a precipitation dataset that NASA has published. So what you're seeing here in this raster image is just individual pictures showing you the amount of precipitation in a 5 by 5 kilometer gridded pixel for the monsoon of 2008. And what is also interesting here is that you can see a day by day analysis of uh, precipitation for your area of interest. So I've put in a pin that I've dropped down here, and it shows me for the monsoon of 2008 there was a dry spell in the latter half of June, and then again then rainfall was pretty much consistent till the end of October. So all of these minor insights are basically what I found super useful about using Earth Engine on a day-to-day basis. Another script that I have is also this is one that I've already shared on the Earth Engine community forum. So this is just a time lapse of the same CHIRPS precipitation dataset, but for multiple years. So you can slide through and easily identify, okay, the 2009 was clearly a drought year. 2008 was much better. 2007 was also better. So again, a quick and easy example of how you can, within seconds, view and understand a vast data set which wouldn't otherwise be easily accessible. So I'd also want to tell you a little bit about the Open Water Data Project. So a few colleagues and I work on this project called the Open Water Data Project. So our broad goal within this project is improving access to water data for users across the board. So this is not just users who already have a technical understanding of remote sensing and GIS, but also people who work in the water sector but don't necessarily have the coding skills, the technical skills required to easily access data. So within that project, we've come out with a couple of things. One is just the open water data precipitation, the open water data app. And within that, you can access the same CHIRPS precipitation data that I mentioned earlier. But this as a CSV for your area or watershed of your interest. So if I quickly go to that slide. Here you can see all you have to do is turn on the rainfall layer, select the watershed, and then you see individual grid pixels, which shows you your watershed, and then you can click on this button and download that data. We also have the open water data resource paper. So this is basically an exhaustive compilation of different kinds of data sets that users studying water resources in India might need. So we've listed down not only remote sensing data sets, but also data sets that are government specific, that government of India specific. So you'll see within it, say for example, the Central Water Commission's not shapefile, but delineation of rivers in India. Then if you want watershed boundaries, then you see USGS hydrosheds, the CWC watershed atlas, things like that. this is a quick scroll through of all of the different data sets we compiled in there. Besides that, one aspect about the paper is also that we've given each data set and what we're calling an open data score. So if so it gives you not just the data set and the link to it, but the time period for which that data is available, the area of for which it's available, the spatial temporal resolution, whether there is a license for that data set, whether license is an open license, whether it's a commercial license, what's the data format, whether it's available as an API or web map service, and whether it's free or commercial. So I definitely encourage those of you who work in water resources to check this out, and also send us tips if you come across new data sets that you think should be in here. And yeah, I look forward to engaging with all of you on the community forum about this. So I guess I'll hand it over back to Pradeep.
Thanks, Craig. That was great. That was a very nice roundup of a lot of work that you guys have put in. I'm sure many people in the community will find the actual outputs and the methodologies and the documentation very useful. Moving on, the next thing would be a little overview that Ujaval will give us about some programming concepts in Earth Engine.
Yeah, thanks, Pradeep. So, good morning again. I see over 30 people on the live stream now. So, thanks for joining. It's great to see this kind of engagement on the very first webinar here. So today, when Pradeep and Craig and Madhu asked me to cover some topic of interest, I thought what would be most suitable would be to cover the programming concepts in Earth Engine that are very different than traditional programming. So one thing that I personally faced and I hear from beginners in Earth Engine is that when you start programming in Earth Engine, the programming model is quite different than what you're used to. So many of you would come from coding in Python or R, or you may have used a desktop software where you have certain workflows. And when you start implementing those workflows in Earth Engine, you quickly run into some constraints where you can't really translate them effectively from what you are used to how Earth Engine works. And for example, there are basic programming constructs like for loops or if and else statement that you find that they are missing in Earth Engine. So rest assured, they are not an oversight in Earth Engine. They are very intentional design choices, and there are equivalent options available to you to kind of use those kind of constructs in a different way. So I wanted to kind of cover that. It is useful material for beginners as well as intermediate users who are kind of used to Earth Engine, but don't really have a good grasp on why these things are. So I'll spend 10 minutes on covering those. Let me share my screen first. So this is the code editor that you are familiar with. This is how you start using Google Earth Engine. And before we dig into the nitty-gritties, I wanted to show you our user guide. Many of you would have seen it, but it's got a lot of rich resource material and it's being updated constantly. There are some new stuff that has been added recently. So I just want to quickly show you how you can get help when you are working with Earth Engine. So on the top right corner, there is a help button. And the first link there is the user guide here. So the user guide is divided into 5 different sections. The first one are the guides. So these are the step-by-step guides. This got some theory. Many of them have a video and have some code samples along with it to help you understand how to carry out certain operations in Earth Engine. So for example, if you are interested in computing textures of images, then you can look at this section of the guide. It has got some theory of what are textures, how you use them, and some code samples that you can quickly copy paste and get started. So very useful. There are a whole bunch of guides available from everything from data import exports to classification, etc. There is also a tutorial section here, which covers basic tutorials of the Earth Engine API, JavaScript, some of the more popular data sets, as well as some video tutorials. So if you like to watch videos and learn, this is great material for all of you. I want to quickly highlight there's a new section here called Data Catalog. This is, if you work with Earth Engine, you know that when you search for a data set, you get some data description about the data. So these data catalog are the new pages where there is a whole lot more information available about the data sets, and all of our petabytes of different data sets are cataloged very nicely with useful material. So I encourage you to check this out, and this is a recent addition. The material that we're going to cover today is under the tutorials tab here. If you click on the introduction to JavaScript for Earth Engine, there is a page that is functional programming concepts, and this is also new. So if you've done tutorials earlier, you would not have seen this. So let me switch back to the code editor. Now the topic of this page is called functional programming, and why functional programming is because traditionally the other programming that you would have done in R or Python is called procedural programming. And functional programming differs in kind of very unique ways. In Earth Engine, if you wanted to process some data, Earth Engine is a parallel computing system. It needs to break down your computation into multiple chunks, and each chunk gets sent to a different machine for computation, and all the results get combined and sent to you. And that's why Earth Engine is very fast at certain operations which are very slow in other systems, because other system would need to process the data in sequence. So if you want to process 10 images, each image will get processed, the next image will get processed afterwards. In Earth Engine, all of the 10 will get processed in parallel. And this is very useful in context of big data and remote sensing, but it also poses certain constraints on the programming, because you need to make sure that each computation that is happening is independent of the other computation. So when you're processing one image, you would not have information about the other images because they are being processed in a different machine separately. So you need to break down your computation into independent functions, and that's why functional programming is a paradigm that is very applicable to this kind of system. So let me demonstrate it, how that differs in implementation. So the first thing we're going to cover is for loops. When you start reading about Earth Engine and see the tutorials, you will see that the use of for loops is highly discouraged in Earth Engine, and most of the API would not even support for loops. So how do you solve a problem like this? Given a problem of, say, a list of numbers from 1 to 9, the problem is compute a list of squares of each number. This is a very simple problem. In Python, you would do something like this, where you would initialize a list and then go through each element of the list, compute the square, and append to the list. Now, this kind of, if you code like this in Earth Engine, it won't work, because this is a sequential programming and Earth Engine doesn't support it. To do it in Earth Engine, you need to apply a functional programming paradigm. And functional programming is essentially defining a function which can work on one element of the list independently of each other. So Earth Engine implementation will look something like this, where you would define a function, say, called compute squares, which takes one number and returns the square of that number. Now, once you have this function, all you need to do is use the operation called map. So take the list, map this function over it, and you get a new list, which are the squares. Now, how does this work? Since the function knows how to compute the square of one number, each of these 10 numbers can be processed independently by the same function, and they can be processed in parallel. And then once all the results are ready, they can be combined together. So theoretically, if you had enough machines available, the time it takes to compute square of 10 numbers would be equivalent of computing square of 10 billion numbers, since all of them can be done parallel. So you can see how this kind of model is very advantageous. So for loops aren't missing from Earth Engine. They are just, you need to code them differently using map and a function. Another kind of constraint you would have is if and else statement. So if I define my problem a little differently, where given a list, I want to compute the squares of only odd numbers. Now, in a traditional programming, you would just say, go through each element, check whether this element is a square or not, and return the square only if the number is an odd number. Now, how can you do this without if and else condition? So in Earth Engine, in functional programming, you need to get a little smart about it. How do you define a function? So here there's one implementation where I've defined a function which says get odd numbers, where when you pass a number, it multiplies the number by its remainder. And if the remainder is 0, you'll get 0. If it's 1, you'll get the number back. So this is kind of a smart way of saying that, I'm defining a function where I get 0 if it's an even number, odd when it's, and the number back when it's an odd number. And once I map this function to my list, I can just remove all the zeros and then compute my squares. And this might seem like a roundabout way of doing things, but in practice, this is very fast when dealing with large data. And once you start getting used to thinking like this, you can become a very, you can code very efficiently in Earth Engine. You may not encounter such problems before in Earth Engine often. The problems you'll encounter are more in nature of working with image collections or feature collections. So say given a collection, you have a collection of images and you want to apply different algorithms saying if the sun angle is greater than 40, do this. If the sun angle is less than 40, do that. So again, you can have an if-else condition in procedural programming like this. In Earth Engine, the way you do this is using filters. So you can divide your collection into two parts using filters, one that is less than 40 sun angle, one that is greater than 40, and then apply different algorithm to both of them. So you are processing both of them differently. And then once the processing is done, you can merge them. So same way of getting, a different way of getting the same result, but this is much more fast and efficient. The last topic is cumulative iteration. There are certain class of problems where you can't really implement in a pure functional way. You need to have some idea of what was done before or what is being done to the other elements of the list. So in that case, Earth Engine provides a function called iterate. Now, I must warn you, this is useful, but before using it, see if you are able to use filters or map to achieve the same results, because the iterate function is sequential and it would take a lot longer to process. So your code will slow down. But this is useful in certain cases. So this is an example of a Fibonacci sequence. If you want to generate that, a Fibonacci sequence is essentially each number is a sum of the previous two numbers. So there is no way you can generate this without knowing which are the past two numbers. So in this case, you can use iterate in Earth Engine, where the iterate function takes an algorithm and an initial value. So you initialize with a certain value, and the algorithm itself has access to the current and previous elements. So then you can compute for each step. It knows what was the result of the previous iteration, and you can generate this. I give you a practical example where I had to use it recently, where I had a bunch of cloud masks, which I wanted to apply to an image in iteration. So I wanted to apply the first mask, then the resulting image needs to be applied the second mask, and so on. And an iterate is kind of an ideal function to use, where you can apply one mask, get the result, apply the second mask, etc. So in the image processing world, this is where you might end up using iterate function. So to summarize here, key takeaways: use map instead of for loops, use filter instead of ifelse, and use iterate when you need to use access to the previous value. So hope this was useful. And if you have questions about this, you can write them in the live chat. I'll be monitoring that, and I can address those at the end of the webinar today. Now I'm handing over to Pradeep, who's going to cover data import and export. Thank you.
Thanks a lot, Ujjwal. Thank you very much. So that was a very good overview of just basic functioning programming concepts and how to do them in Earth Engine. Of course, pretty much all of us who does quantitative analysis, we know that some programming concepts, they are just fundamental and they occur very frequently, no matter what you try to do. And when one is trying to learn a new tool like Earth Engine, to see that it doesn't have the same familiar named keywords like for and if and so on, I can remember myself, I used to feel a little thrown off, but the overview you gave is a good roundup of how all of those operations is very much possible in Earth Engine, and it just takes a little bit of rewriting of code and rethinking of how to organize data and code. So thanks a lot. So I thought I will say a few words about data import and export in Earth Engine. So the motivation is the following. As most of you probably have already discovered by now, the users of Earth Engine come from very diverse backgrounds. And they come from different programming language background, different kind of data they use. Sometimes the data can be proprietary, they could be public and all of that. Earth Engine data catalog is really good in making available a whole lot of publicly available data sets, and importing them and so on are very easy to do. So the pointers that Ujjwal mentioned while giving an overview of the documentation, if you go back there, you will find plenty of pointers on how to search through those catalogs and import them into your script and work with them. But like I said, many of us are also sometimes interested in just using data that may not yet be there or may not be there at all. It's just proprietary. Maybe you even purchased it. It's not free at all, and so on. So the good thing about the way Earth Engine is structured is that you can bring all of that data into Earth Engine and use Earth Engine computation resources just fine, just like you would be using any of the data sets already on their catalog. So I thought this would also be something interesting and useful for beginners to know, namely the fact that if you go looking for your favorite data set in the catalog, and if you don't find it, that's not a showstopper. You should be able to, if you can get your hands on that data set yourself, you should be able to bring it into Earth Engine and use it just like any other data. All the computation resources and all the advantages apply just the same. So just to give a quick overview of what I'd like to cover, I'll go over quickly the concept of Earth Engine assets, because that's how the data are stored in Earth Engine under each user. The assets can be either raster or vectors. They can be input data that you bring in, like I just mentioned, but they could also be intermediate or final results coming out of your analysis. The advantage here is that the scripting and the API for Earth Engine allows for very easy read in and write out of data from within your own script, and they can go into assets and they can go to one or two other locations as well. We'll come to that in a minute. Also, I wanted to say a few words about the ownership of the data that you work with and bring in and all of that. Just a quick pointer that the Earth Engine developers resources that Ujjwal pointed to, that also has an entire section on data, bringing in your data, and so on. It's under asset management, and you can look through it at your leisure. So just an overview of the Earth Engine assets. Once you sign up for Earth Engine, by default, you get a free storage of about 250 gigabytes in your asset space. You can see that when you go to the Assets tab on the left of your code editor window. You can make new assets, you can organize them into different folders, you can, and uploading of raster or vector data happens through this window. You'd go to the Assets tab, click on New, and follow the instructions to upload. And if you're familiar with working with image collections in Earth Engine, it's encouraging to know that if you want to upload an entire set of images and work with them as an image collection, this interface in the Assets tab makes that very easy also. You can upload all images individually and drag and drop them into a new image collection you make, things like that. So the UI for this tab is built to be fairly useful and flexible with just clicks and drags and so on. Of course, for those of you who might want some more fine-grained control on these assets, that also is possible, but that will involve some installation on your local machine. You'll have to install a Python API, and you will then be able to do much more fine-grained control of your assets through what is called a command line tool. And like I said, all of this is mentioned in the developers' resources. I encourage you to check it out when you feel the need for it. Coming to the part of bringing your data in, so typically you would upload them from your local machine. If you're working with rasters, that would be GeoTIFFs. The system puts a cap of 10 GB per image of upload. So if you have to upload larger files, try to break them up into smaller chunks. Rasters, so the raster assets can also be TensorFlow records. Just a shout out to TensorFlow. That's another Google Cloud Computing platform for machine learning. And only very recently, Earth Engine and TensorFlow got integrated for much more seamless and easy working together. And many people find it very useful when they're working on large geospatial data, like what the Earth Engine's strength is, and TensorFlow computations, which is basically very strong with machine learning. So one of the ways you seamlessly transfer data and talk to each other between Earth Engine and TensorFlow is by using raster assets in your Earth Engine account. So the other nice things to have also is in the same UI, there is facilities for editing and setting important properties you might have on your data sets. So for example, date for an image or any vector data can sometimes be very important. You can set it right there using the UI and go from there. Coming to the vector data sets, those are stored in Earth Engine as stable assets. That's what they're called. When you want to upload your vector data set into Earth Engine, you should make them into a shapefile and upload the entire shapefile. Just remember to include the accompanying files along with the SHP file, like for example, DBF and SHX and so on, while uploading your shapefile. Optionally, you're encouraged to include the .prj file as well, because that's what contains the projection of your data. And just know that if you forget to or choose not to include that in your upload, then Earth Engine will by default assume it to be a common coordinate system, which is lat-long WGS 84. Just the shapefile itself, there's another alternative you can use to upload, which is a zip archive of the entire shapefile and its accompanying files. Just be sure that a single zip archive that you upload will contain only one shapefile, and that there are no duplicate file names. If these are not met, then it's possible to get Earth Engine confused, and the upload might fail. You might be prompted to check for these mistakes and re-upload. There is an additional way of getting tabular data, vector data into your Earth Engine analysis, and that is via what are called Google Fusion tables. Some of you may already be familiar with it. This is very widely used in a lot of map making and data archiving and managing and visualization and so on. So if you're familiar with that, that's what this is. The good news is Fusion table can get read right into your Earth Engine script as a feature or feature collection. And the way you would make a new Fusion table is one of the ways is by uploading a KML file. So basically, if you have a vector data to upload, you would want to make them either into a shapefile or a KML and upload it, and make sure you follow these functions, these conditions. You might sometimes want to also take your data out because maybe you're done analyzing, or maybe you just want to download some data that's already up there, and so on. So the way to do that would be to export data. Images would get exported as GeoTIFFs or TensorFlow records. Vectors can get exported as any one of comma-separated value file, shapefile, GeoJSON, KML, KMZ, or a TensorFlow record. There are multiple destinations you could export your data to. One is the asset, the Earth Engine asset, which I just talked about a moment ago. There's also the Google Cloud Storage, which is another option. Both of these are in the cloud. Of course, in the cloud also is your personal Google Drive space. So there are advantages and disadvantages to each of these options. For example, asset and cloud storage, they are very suitable for intermediate results because Earth Engine API allows for very seamless, quick reading in and writing out of data from assets or cloud storage. Typically, the assets also tend to have larger space availability, and cloud storage also is typically much more space that you can work with. On the other hand, Drive will have a few limitations, like the space, for example. By default, Drive has a much smaller space availability than either asset or even cloud storage. But when you want to bring data back into your local machine, for example, it is possible that Drive is your best option because that's right in your personal account. It's easy to point, click, and say download, and it comes right in. But the assets and data in the Drive cannot be read into the script so easily as if they were in the asset or the cloud storage. So just ease of use and size of storage availability and so on, these are the trade-offs between these options. Depending on your needs, one or the other might work out best. While you're exporting data, just a few things to watch out for. Earth Engine API itself is built to be very flexible in how it handles data, how it handles data, computes on data, and transforms one from another, and so on. But when you are talking about bringing in your data or taking data out of there, you will be constrained by file formats of some of the popular file formats that are in use. So for example, if you have raster images to bring out of Earth Engine that come out as GeoTIFFs, let's say, they have some GeoTIFF as a format has some constraints on what the band should be like and the data format in the bands and so on. So when you're exporting data out as a GeoTIFF, you might be limited by some of these constraints. Of course, these are quite generous, but the Earth Engine API itself handles more flexibility than some of these formats allow. So something to keep in mind while moving data in and out of Earth Engine. Similarly, shapefile, for example, has its own constraints as a file format. The geometry types, for example, have to be consistent and so on. So these are just some things to keep in mind while working with specific file formats. Also, Earth Engine, because it's a cloud computing platform and it's a shared resource, typically at any given point in time, there are multiple, I don't know, I'm not sure about the numbers, but surely hundreds or even more people parallelly working with the Earth Engine shared resource. So Earth Engine itself has a few guards against inadvertent large exports, for example, just so that some user just absent-mindedly doesn't end up initiating large exports and take up too much of the computational resources and time. So these guards are, again, like I said, very generous, and you typically don't bump into them while working, but sometimes you might. And in that case, the documentation is very clear on what to do to get around it, how to reduce file size, reduce export sizes, things like that. So all of this, of course, is easily available at the link at the bottom. It's a page in the developers resources. Other than just data exports, which everything I said so far holds for rigorous analysis, let's say scientific analysis, where you would have to bring in data, take it out, do more analysis, things like that. So that's one thing, but sometimes you might want to bring data out of Earth Engine just to visualize. And that is also very nicely laid out in Earth Engine. For example, if you can have an entire image collection of images, and you could export it into MP4 videos. It gives you flexibility to set frame rates, scales, dimensions, and so on. And the video can go into your drive, cloud storage. So depending on how large you expect the file to be, you could choose one or the option. The other visualization option might be to export an entire map. So maybe you did a bunch of data pulling and analysis and all of that and laid it all out on the map viewport in the code editor, and you're very satisfied with it, and you want to bring it out just as a map, so it is more publicly accessible. Maybe you're building another website or something like that. So that kind of thing is also possible to do. So you can export an entire map, and that goes into cloud storage, and that works very seamlessly with the Maps API. That's also another Google service that you can make use of. And also these maps can be ported into Google Earth. And if you guys have had a chance to look up Google Earth on the web, it's a really nice visualization, and being allowed to bring your data into Google Earth and use the visualization in Google Earth can be very powerful for some applications. Of course, these exports also come with many tweaks and knobs that you can set to control parameters of your maps and exports. And lastly, a word about the data accessibility, sharing, ownership, and so on. Just want to take a few minutes and say, because I'm sure this is important for work that many people do and something that people might be curious to know. So all your data, like for example, whether it's in your asset or in your drive, it is private by default. And having said that, all of that data are also shareable to individuals, domains, or publicly to all, as you wish. Default asset and drive storage, of course, is free, but cloud storage and access may be charged. You can potentially get more data, more space for data, but potentially may be charged. But also something to keep in mind is there are free trial period offers and free cloud credits programs that you can apply for and take advantage of. And maybe all of those will come in very handy for your analysis and visualizations. So that's it from me. Like Ujaval said, any questions you might have, feel free to ask them on the live chat, and we'll come back to them at the end. Thanks. Next would be Craig would take over to say a few words about the community forum that we are building and the online group that we are building.
Thanks, Pradeep, for that summary of getting your own data into Earth Engine. That was very useful. I'm going to talk a little bit about the users community through which most of you guys would have heard about this webinar. So the first question is, why have a community in the first place? This is something that Pradeep, Madhu, and I sort of discussed a lot initially. We were wondering whether we knew for sure that there are a lot of people working on remote sensing in India, but we felt that there's still a lot of space for collaboration. So, for example, I mean, you have your remote sensing institutes, GIS institutes, and colleges, where there are people within the institute itself who you can seek help from, get feedback from. But when it comes to a broader community within India, there isn't, I mean, that community so far doesn't exist yet. So just to clarify initially also that this users community forum, one, it is not meant to replace the technical developers forum that you see on the Google Earth Engine API page. So this is just an India-specific community. It's we can also discuss technical issues, but it's also we hope to also encourage a lot of discussions around so events and meetups, collaborations of different kinds. And yeah, just, I mean, introduce yourselves on the forum. Tell us a little bit about the different kinds of topics and research that you guys are working on. We'd also encourage, this webinar series that we have, we'd also encourage some of you who feel that you've done a little bit of analysis, you've done, you've put in your work, and you would want to share what you have with others in the community. Besides sharing your code on the forum, you can also reach out to us and tell us that, okay, I'd like to present a little bit about the work I'm doing, and when can we do that? So this webinar series is going to be a once in a month event taking place on the first Saturday of every month. So you can come back to this page to find details for future events. Yeah, so just looking forward to engaging with all of you on the forum, and I think we can now switch over to questions.
Thanks, Craig. I think just before we go to questions, we have a quick round of quick one or two announcements that Ujwal and Devja had to make. So over to Ujwal, Devja.
Yeah. Hi. So I think this is like a really great timing for this webinar. We at Google we have been thinking of putting together a contest, and this is only for Indian users. This is the first time as a team we have done a contest, and it is meant only for Indian users. So and it's going to be announced very shortly. But as a sneak peek, Devja will give you a little bit more details about the contest and where you can learn about what the contest is. So Devja can take over and announce that.
Yeah, thank you, Ujwal. Yeah, as Ujwal said, this is the first time we're doing a contest on Earth Engine. And I'd like to mention that it's open only for Indian university or college students. You can be enrolled in any academic program, be it undergrad, master's, or PhD. But only students, full-time or part-time students, are eligible to participate in this contest. And let me just quickly share. I don't know if all of you are subscribed to the Google APAC events mailing list, but in case you're not, please do so. And let me just check quickly. So yeah, this is basically the announcements mailing list. So if you're not, once the webinar is done, please subscribe here. We'll be announcing here and we'll be posting on our user forum as well. And again, to quickly come back to a brief overview of what the contest will be about. So this contest, as I said, only open to students, and it'll be carried over the period of 2 months. We're conducting it in 2 rounds. The first round will basically comprise of 4 problem statements. We'll have supporting starter scripts and a few quantitative questions for you to solve, very interesting problems. And everyone who answers questions in round 1 correctly and qualifies round 1 will be eligible to participate in round 2, which will be a classification challenge. So yeah, that's a brief overview of what the contest is going to be. As I mentioned, we'll be launching it early next week. So please subscribe to the mailing list, as well as keep posted on our community forum. And we'll be posting in both places. And again, do spread the word about the contest. There are exciting prizes to be won. And we'll be announcing all of that next week. So thank you.
Thanks, Devja. That's great, something exciting to look forward to. Okay, so if you have any questions on the live chat, we can take them. So there are a bunch of them I can see. Functional programming is the only way to program, or is it just an efficient way of doing things in Earth Engine?
Yeah, I can take that. So really good question, and very kind of insightful question as well. So in Earth Engine, if you see, there are functions that are available for loops and if statements. So there is an algorithm called ee.algorithm.if. You can use it within your functions to do if and else conditionals, but they are discouraged. So if you used if, the same operation that you are using will be slower than if you were to use filters. So it's just more efficient to use a functional programming paradigm when using it. For certain cases, the e.algorithm.if is available. Similarly, there is for loops available on the client side. So when you program in JavaScript, you can actually go through each element of the collection and process them using JavaScript for loop. But again, they'll be much slower than what if you had used map. And so again, they are discouraged. There are certain edge cases where you might want to use them. So those are, if you want to look at those, there's a client versus server page in our documentation that you can see some of them. And some of them will be useful when you're developing UI apps. So apps is something that is recently launched. We'll cover that in the future sessions. But if you're developing apps, they are client side. So they are running in users' browsers. And there you may need if and else controls or for loops. So there you may want to use them. But for doing your data analysis in Earth Engine, you would rarely need some of those. So use map and filters instead. But great question.
Yeah, thanks, Ujwal. Next, quickly on to the next question. So one of the questions is about, can I take old data of high resolution map images from Google Earth, and how can I download GeoTIFF file? So I'll take that quickly, and Ujwal, correct me if I'm wrong with any of the details here. But so the Google Earth and Google Earth Engine are very different products. And perhaps the chief difference is Earth Engine has public, free, open data sets, and Google Earth typically has a lot of proprietary data that Google has paid money to purchase. And just the terms and conditions of all of those don't allow for them to be used in an open setting. So generally speaking, Google Earth images, no, they can't be used in Earth. I mean, they can be used if you can get them yourself and keep them private and use them. But what is already available for you to see freely on Google Earth, they can't go into Earth Engine. And similar to this is a question on what's the best way to look for small objects like airplanes in Earth Engine, and what about object-based detection in Earth Engine, like it is done in deep learning techniques. So again, I think one constraint about detecting objects would be the resolution of imagery you have, and that again speaks to the proprietary versus public data question that I just went over. So public data sets are typically much lower in resolution than many of the really pretty looking images that one enjoys on Google Earth and so on. So can object-based detection be done in Google Earth Engine? The answer is yes. But whether you can use those tools to answer the question that you're interested in depends on the resolution of the data you're working with and size of the objects and how those two play with each other. So
I just wanted to add something to what you said, Pradeep. I've posted a link to a question asked by Shubham Gupta. So there's a link to a session from the Earth Engine User Summit, which shows how you can use Earth Engine with TensorFlow to identify cars. So that, I mean, can be, if you had the imagery with which you could do this, there's a walkthrough that, I mean, it's a training session of an hour and a half that gives you a very good idea of how this could be done.
Yeah, and so TensorFlow would be the right tool. And Earth Engine can be used in conjunction with that. I've also posted the link to the talk about TensorFlow and the video. Maybe Devja can post in the live chat as well. So yeah, that would be it's possible, but you need the access to high resolution imagery.
Yeah, great. So there's a lot of resources available on TensorFlow and TensorFlow talking to Earth Engine and all of that. And those are all online, and we can share those links as well. Yeah, hi, Craig. Yeah.
Button a little bit. Since one of the requests is have a session on supervised classification, I'd also like to briefly talk about an effort that Madhu and I were discussing for a while, which is pooling together to put together an open data repository of training points. So basically, many users within Earth Engine, especially if you're working on India-specific issues, one thing that you quickly realize is that the training data that you need, whether it's land use classification or forest classification or whatever specific issue you're looking at, the training data just doesn't exist, or if it exists, it's proprietary or it's enclosed in silos. So one thing I've just been noticing is that a lot of people are reinventing the wheel when it comes to training points. So that's something that we're definitely going to look at in future sessions, and we invite collaboration on that.
Yeah, great. Yeah, that's true. That's a good announcement. Thanks, Greg. So moving on to another question. Are there specific functions or features in Earth Engine that process microwave SAR images? So quickly, I'm by no means an expert with SAR data analysis, but I do know that there are SAR data available on Earth Engine, and there are tools available. Earth Engine tools can be used to process them, and there's a lot of activity on the Earth Engine community developers forum, which has talked about processing this kind of data. So that's definitely one place to go look.
Yeah, definitely. Sentinel-1 SAR data is already available and accessible on Earth Engine, and there are multiple scripts to use that for water detection, water occurrence with different thresholds. And so we'd encourage you to check out the main Google Earth Engine developers list for discussions on SAR data. With respect to RISAT data, yes, I guess if you have access to RISAT images, you could import that into Earth Engine, as Pradeep talked about earlier, store it as an asset and analyze it similarly.
Yeah, one quick thing I wanted to add to what Craig and Pradeep have said. Yes, it's possible to analyze radar data. There was I'll post a link to a small app that I did to detect floods using Sentinel-1 data in the recent Kerala floods. And there are many radar-based algorithms that have been ported. And what's very nice and a good reason why you should go back to the full forum is you get, for example, despeckling is an important part of working with radar data. And there are scripts that people have worked on that are available for you to straight away go and use. If you use the developers forum, that's a lot of resources like that one is able to get straight away. And that's a lot of work already done for you.
Okay, great, thanks. Another quick question, is it possible to overlay lat-long grid over a map? Yes, it is possible to do so, and we'll post a answer to this with a script at the end of the webinar. So
I just posted.
Okay, great, thanks. Yeah, we are running out of time for today. We will maybe take just one more question and then call it done for now. And that would be, does Google Earth Engine tend to overestimate vegetation through NDVI? And this person says he or she has used Landsat data for vegetation cover. Latest Landsat 8 images show that the vegetation cover has increased tremendously. Is there a way to verify the results?
So I think that question definitely would require some of us to take a look at that script. So I think that was Yogesh who asked that question. So I asked him to go ahead and share his script on the forum so others can take a look at it, giving feedback on the issue.
Yeah, great. From the little experience I have had with vegetation indices, I'm not sure exactly what you mean by overestimate vegetation. Vegetation extent, growth, there are multiple, clearly, as you all know, there are multiple aspects to vegetation. Any one vegetation index, whether it is NDVI or EVI or any one of the others that you might be working with, just one index by itself tends to be a little it tends to be a little difficult to make strong inferences based only on one. So I can see that it can be a difficult problem to work on. But like Craig said, we can, if this can be posted on the forum, I'm sure there are many experts on remote sensing and vegetation quantification and so on the forum, and maybe they can jump in and share expertise, and we can all learn from there. Okay, so we will round it up for now. Thanks a lot for everyone who could join today. We had a great time hosting this, and I hope you guys had a good time too, and maybe something useful came out of it. Like we said earlier, this recording will be made available on the YouTube channel for the Earth Engine users community, Earth Engine India users community. So anytime you feel like, you can feel free to come back and check it out. And again, just a reminder that the group forum online, if any of you hasn't subscribed yet to that forum, please do so. More of us and more of our skills coming together, that will just foster more sharing, and hopefully we'll all learn from each other and so on. So thanks a lot. Thanks Devja and Ujaval for joining us today. And Madhu, Craig, thanks a lot for coming around as well. We will see you on the next webinar. Thanks.
Thanks, Pradeep.
Thanks.
Good job.